Hello everyone, and welcome to Achieving Near Zero Downtime for SAP Systems. I'm Mike Friesenegger with SUSE. I'm a solution architect working with the IBM Global Alliance. In particular, for this presentation, I'll be talking and co-presenting with our friends in IBM Power, and I have Mark Gordon as my co-presenter as we go through the session. Mark, you want to introduce yourself?
Yes, thanks, Mike. Hello, so I'm Mark Gordon, and as Mike mentioned, I'm part of IBM. I'm a client technical specialist. That means I support our clients, companies that are implementing power systems, in particular using SAP products. Thanks, Mike.
All right, thanks, Mark. All right, let me just take a moment and talk about the agenda. And so during this session, there are a number of things that Mark and I will cover. First of all, we'd just like to very quickly review what RTO and RPO mean to organizations and why that's important to availability and making sure that, that systems stay up. Then we're going to talk about several different technologies that work within SUSE Linux Enterprise Server for SAP applications, as well as on IBM Power Systems. And then we'll go ahead and wrap it up and get you back to whatever else you're doing during your day. Mark, you want to go ahead and talk a little bit about RTO and RPO?
Sure, thank you, Mike. So as Mike mentioned, first we're going to talk about the concepts, what our goals are, and then Mike will talk about specific products. In particular, if we're looking at this business continuity and recovery, the key factors to consider are what your recovery point objective is. That is, can I afford to lose any committed data? And then secondarily, the recovery time objective. How long until my recovery system is up and running and available to do productive work? RPO and RTO are a function of business goals and the characteristics of the system. As a, for instance, if you have a system that's a data warehouse system that receives ETL feeds, then your recovery point might not require all committed data because you can just rerun an extract if it was in the middle. Whereas if you've got a transactional system, if you're a bank, then you can't afford to lose any transactions at all. So those are the two factors that go into the design. And then as you can see in the examples below, there are a number of different choices that you can choose that have different costs associated with different recovery points and recovery time. That is, an example being backups. And this is just a process for moving the data. Backups, low cost, whereas you're going to lose potentially up to a day of data if you copy every day, and the recovery time is high. Storage replication. Replicating storage can be done. You can do it with a recovery point of no committed data loss or with a lag, depending on the distance. But you need to wrap around it some sort of automation process, such as VM Recovery Manager, which isn't discussed today, in order to be able to copy and automate the restart. And then last, there are a couple of scenarios that Mike will be discussing in more detail using HANA System Replication. HANA System Replication is a capability built into HANA where changed data can be propagated from the primary live system to a secondary system. And there's options for doing that where it's optimized to restart as fast as possible to minimize the recovery time, or to use resources as efficiently as possible, but at a cost of slightly more recovery time. And then additionally, when we talk about automation, there are possibilities to restart services. Some of the SAP services, such as Message Server, can be restarted in place if they fail. Message Server is stateless, whereas other services, such as NQ or HANA, are not stateless, and then would need to go through a recovery process in order to restart. I think that's all I have for this section, Mike, if you'd like to take over.
Okay, thanks, Mark. So let's talk about some capabilities specifically in SUSE Linux Enterprise Server for SAP applications. So with SLES for SAP, it includes our HA extension, and more specifically, it includes a number of SAP-specific resource agents. This slide focuses on the resource agents that are for SAP HANA, for both scale-up and scale-out SAP HANA deployments that are utilizing HANA system replication. We, as joint partners, SUSE and IBM, have very large and some very complex SAP deployments with SLES for SAP on IBM Power Systems that are using the SAP HANA resource agents that are included in SLES for SAP applications. So Mark started touching on some of the capabilities. Let me spend a little bit more time talking about some of the HANA system replication options that we support with our HA agent. First of all, we support performance optimize, where you have the primary HANA database servicing the organization, servicing customers, answering requests, having rights to the database and things like that. As changes are being made to the database, the data is being replicated to node 2, as you can see it there on the right-hand side. This is all happening over the network. Node 2 basically has the majority of the HANA database preloaded into memory. There are certain things that cannot be preloaded into memory, but the majority of the database is preloaded into memory. If for some reason node 1 fails due to a hardware failure or some kind of operating system issue or maybe an application issue or whatever, a user issue, the HA extension and specifically the resource agents are monitoring that state of node 1. And if it sees some failure, it might try and restart some of those processes on node 1 because that's a lot less intrusive, takes a lot less time. But at some point, if it cannot restart those resources or those processes, or there's a configuration that says don't restart, just immediately fail over, then what will happen is node 2 will need to become the primary, and node 1 will need to be shut down. In not that specific order. Actually, node 1 will get shut down first, and then node 2 becomes the primary. We always want to protect the data. That's what HA does with performance optimize, in that it's monitoring node 1. If it sees any failures on node 1, it shuts down node 1 and then promotes node 2 to becoming the primary. All doing this automatically, all without human intervention, and all happening very quickly, so that there is your RTO, your time to recovery is actually very short. For many organizations, performance optimize is a possible waste of resources. They want to be able to use that node 2 system for other work versus just sitting there waiting to take a failure and be there for a failure. That's where cost optimize comes into play. In this case, node 1 has another HANA database running on it, whether it be a quality database or a development database or something like that. Node 1 is acting as the production, servicing all the production requests, and everything is being replicated via HANA system replication to node 2. But in this case, the majority of the data is being committed to disk versus being stored and ready to go in memory. What that basically means that if node 1 fails, HANA, or HA is going to detect the node 1 failure, but now it's going to have to do some extra steps. It's going to make sure node 1 finishes, gets shut down properly. Node 2 is going to have to first shut down that QA or that development database, cleanly shut that thing down, make sure it's down, and then bring up the HANA database that will become the production database that was on node 1. That's what cost optimize is all about. And if you look in the lower left-hand corner, you can see the chain topology where you have node 1 and node 2, either running in performance or cost optimized mode, typically in the same data center. or data centers that are very close to each other, and typically running in what we call synchronous mode, HANA system replication synchronous mode. System 3 is in another data center that's typically further away, just in case there's some major failure within a city, or maybe it's outside of a metroplex or whatever. In this case, it's more of an asynchronous replication. There is a possibility that data could be lost as data is replicated from node 2 asynchronously to node 3 or system 3 in this picture. But ultimately, our HA technology is focused on protecting node 1 and node 2 and automating the failure of node 1 and node 2. We have chosen to not automate the failure between node 2 and node 3 because it's asynchronous replication, because there's a possibility for data loss. The last thing we want to do is cause an organization to lose data. We want to allow the SAP HANA administrators, the SAP administrators, and those people that are involved make the final decision when it's time to cut over to node 3 or system 3 in this example. And lastly, not only do we support scale up in like the performance optimized, cost optimized, and in the chain topology, we also support scale out HANA deployments. In this example, you can see scale out, and we have a scale out HANA resource agent that can be used. So very quickly, I just want to highlight a couple of topics that I think are very important when thinking about doing HANA system replication and utilizing the HA resource agents in SLES for SAP applications. And those two topics are related to the fencing agent or the Stoneth agent that you'll use for IBM Power, as well as the watchdog. And so the fencing agent, or what we refer to on tongue-in-cheek as Stoneth, shoot the other node in the head, that agent by default, in many cases, in most organizations that I've seen, are utilizing SBD, split brain detector agent, and it's utilizing iSCSI back storage for being able to have a shared storage area. Now, there are customers that do different shared storage options, but this is what I've seen in most cases with IBM Power customer deployments. As well as in most cases, I've seen customers utilizing the SoftDog watchdog, the software-based watchdog. Now, there are some reports that I've seen where there's possible data loss when using the SoftDog if the system becomes unresponsive. You know, the SoftDog is basically monitoring the system, and if the system doesn't report back that it's operational to SoftDog, SoftDog is going to reboot the system, thereby kicking in the HA process and causing a failover. Well, to be honest, SUSE has not seen this, even though we have heard of reports about this. We have not seen this. And really, when it comes to the highly reliant and very powerful IBM Power-based systems, these systems are extremely capable, and so we don't typically see systems that are just going to lock up and cause SoftDog, that watchdog, to stop responding and things like that. So if you do find this issue, please let us know. But as of now, we've not seen any reports of this, and think it's just something that is being set out there to maybe create some FUD around using SBD and with iSCSI and also the software watchdog. So now let's switch over to another aspect of HA and another thing that SUSE does with SAP, and this is in particular focused on protecting the SAP NQ replication. So prior to ABAP 1809, SAP used ENSA 1. ENSA stands for NQ Standalone Architecture for syncing the lock table. So this is the lock table for locking records within the SAP database, who has the record locked when they're updating payroll or updating ECC record or whatever. In the ENSA version 1 configuration, some drawbacks existed. First of all, it only worked with the 2-node HA configuration, and so you could not scale beyond 2 nodes, which is a recommendation when you want to set up a truly highly available infrastructure. The other thing is the NQ replication server. In this example, it's the ERS. The ERS, the NQ replication server, used shared memory segments. So if, as the ASCS, the ABAP Central Services, was managing the lock table, the ERS was actually replicating those shared memory segments to the secondary system. If the primary system where the ASCS was running had a problem, died for some reason, then the ASCS had to be restarted where the ERS was running. If that didn't happen, then there was a possibility of losing the lock table, losing the locks, and causing significant issues for SAP deployment. With ABAP 1809 and newer, SAP has gone from using ENSA 1 to ENSA 2, as you can see on the right-hand side. This is network-based replication, no longer using shared memory segments. It works with more than 2 nodes. Like I said, it's a recommended HA design to have 3 or more nodes, have an odd number of nodes to be able to strategically place those important services and not overload one specific node. So as you can see now, in this example that I'm looking at here on my right-hand side, it shows only 2 nodes, but it's important to know that we now support multiple nodes within HA cluster for ENSA 2, and this all was certified back in early 2019. SUSE achieved this new SAP certification for ENSA 2, and actually we were the first cluster vendor to be able to achieve the certification. We focused on getting it certified for SLUS for SAP 15, but this can be done with SLUS for SAP 12 SP4 and newer. So you have the flexibility of using both major versions, SLUS for SAP 15 and also SLUS for SAP 12, if you want to take advantage of the ENSA 2 replication with ABAP 1809 or newer. So on this slide, I just wanted to highlight the best practices that are available for you as you are researching how to make this work. These SUSE best practices are architecture independent because it works the same regardless of whether it's on an IBM Power-based system or whether it's on other architecture like Intel architecture. But I absolutely recommend downloading this presentation, clicking on the links to read up, scale up, performance optimized scenario, or the scale up, scale out performance optimized scenario for HANA system replication. And if you're going to be setting up NetWeaver and doing NQ replication for S/4HANA, we talk about how to do that in the guide here. This presentation was never intended to be an end-all be-all about everything you need to know about all of the HA options. I'll leave it up to the really smart guys like Fabian and Bernd of our SAP team who are working with SAP directly. They're SUSE employees working with SAP in Waldorf, and they've got a session that you'll be able to watch, and I definitely recommend watching it. It's called SAP HA. On SUSE, all you need to know. It's a technical tutorial session. I love listening to these guys because you learn a lot about all of the HA capabilities. And as well as check out several other SUSECON sessions that focus on using SUSE Linux HA with SAP. So Mark, I'd like to turn it over to you.
Okay, thank you, Mike. And yes, before I go on, I would like to second Mike's comment about the the guides available from SUSE for the best practices for scale up, scale out. They are very complete and very useful. So now we'll shift gears and head on to kind of a related topic. We've been talking up until now about how to minimize downtime using automation to handle failures and how to minimize the data loss as a recovery point for the related topic. Now we're going to shift gears a bit and talk about, for normal operations, how can we minimize the time that our system is unavailable. And one of the things in normal operations is that every now and again one has to shut down HANA or shut down an LPAR. And there's a capability available combining the features in Power Systems and HANA and SUSE 15, so it's 15, called BPMN, Virtual Persistent Memory. And functionally, what it's going to enable is a faster restart of HANA or a faster shutdown. It's available on Power 9 systems. And the way it's going to do that is that when virtual PMM is used, that there will be a persistent copy of the database stored in memory, persistent across HANA shutdown, persistent across the LPAR shutdown. Normally when HANA starts, all the row tables are loaded, all the column tables are loaded, indexes that are implicitly built on all the various columns in the column tables are built. And so the process of loading and building those implicit indexes can be bypassed because they're already built and in memory in the BPMN structure. So BPMN is looks to the operating system like a file system. It's been configured as a file system, but in reality, it's configured in the HMC, as you can see here on this diagram. HMC, you configure a volume. The volume is connected to the LPAR. When the LPAR starts up, it sees volumes being available. The administrators then configure those volumes for a file system. They configure HANA to use the file system. And then when HANA starts up, it will read the data from the data files and the log files. That persistence on disk continues to exist and continues to be needed. But then it will copy it in the runtime usable structure into the BPMN file system, and thereafter it'll be used from there. Now, there are other offerings available, from other vendors for persistent memory also. The BPMN, as we show you here, has the benefits that there's no additional latency, that since BPMN is based on DIMM memory, it has the same latency that your memory always has, and so your reading and write operations continue to operate at the same speed that they always have. We've seen in our testing that we've done in our labs that we've gotten up to a 17-fold increase in the speed, well, I guess 17-fold reduction in start time for HANA, where that is starting in 1/17 of the time required previously, and a 30% improvement in the shutdown time, testing with a 48-core database, 8 terabytes. BPMN can be used on virtualized systems, and so it gives you the flexibility. If you have multiple HANA databases on a single frame, some of them could be using BPMN, the ones that have the most important requirements to speed up normal shutdown and restart, whereas others might be configured without it, and gives you the flexibility there. And that differentiates it from some of the offerings that are available, where there are hardware features not available for virtualization and only can run natively. Mike, I think that's it for my summary on BPMN. If you'd like to take over.
All right, thanks, Mark. I think BPMN is a very cool technology that that every Power 9 customer ought to be taking a look at and taking advantage of, because there's absolutely no cost. It's just getting it set up and following the guides that have been put together by IBM and SUSE. So continuing that operational aspect and looking at ways to minimize the time, the downtime that is created from operational changes that are happening on a system. One of the biggest issues that we have seen, that we have focused on addressing with SAP HANA systems, is the need to reboot because of a kernel update. And I think a picture makes live patching much easier to understand. So if, and you can see 10 months here, where there's a number of critical vulnerabilities that have been, that would require the Linux kernel to be rebooted. And if an organization was forced to reboot every single time, with a virtual PMM, yes, it would be faster, but still you'd be taking your users away from their data, bringing down the system for a period of time, which for a mission-critical system is the last thing that organizations want to do. When there is a vulnerability, wouldn't it be great to be able to apply the fix to the kernel and not have to reboot? Well, that is possible with SUSE Linux Enterprise Live. And like I said before, a picture is worth 1,000 words. It makes it a lot easier to understand it. And as you can see here, those same critical vulnerabilities can be applied to a running kernel that's running a HANA system, and the system does not have to be rebooted. Actually, you can go up to 1 year without rebooting the system with multiple live patches applied. So I'm all about pictures when it comes to understanding live patching, and maybe you've seen this before, but I think this is a great picture that shows how live patching works without getting into great detail. But kgraph is the SUSE implementation of the Linux kernel live patching with the capabilities that were merged into Linux kernel 4.0. And specifically ftrace functionality that was merged into Linux kernel 4.0, it created the ability for us to create a detour around broken functions in the Linux kernel. So we're not talking about replacing a huge piece of Linux kernel. Typically, these are small functions, and that would have a vulnerability. And that function, that small function, would if that vulnerability had to be fixed immediately, it would require a reboot before live patching. Now with live patching and with kgraph, or SUSE Linux Enterprise Live Patching as we call it, that's the name of the product, now with that installed, we just basically create a detour around the old function to the new function that is fixed. The benefits that it provides are twofold. One, it requires no stoppage of the kernel to enable live patching, to install live patching, or to enable a specific live patch. There is no stoppage of the kernel, as well as there is no latency to the application, in this case HANA, as the live patch is being applied. Things keep moving, HANA keeps working at full speed, and the patch is applied as the functions are being called, and the ftrace is doing its job of redirecting or creating that detour for any existing functions that are happening in memory that need to be redirected. So here are some key highlights for SUSE Linux Enterprise Live Patching. First of all, there is no, like I said, no runtime performance impact and no interruption of applications. I think that that's really important. That's a differentiator when utilizing SUSE Linux Enterprise Live Patching. SUSE has stated that we will focus on kernel bugs which affect CVSS, or also known as critical vulnerability scoring system, CVSS v2 greater than or equal to 6, or CVSS v3 greater than or equal to 7. What that basically does is it sets the threshold of what type of vulnerabilities that we will apply a kernel live patch for. We're also looking at doing live patches for kernel bugs that affect data integrity or affect system stability and things like that. We want to make sure that the system stays stable and is also very secure. You can apply these patches manually. There's a KLP command that allows you to interact with kernel live patches. But if you're working in an SAP environment, you typically have a large number of systems you're managing for production, for QA, for dev. We definitely recommend and suggest utilizing a Linux systems management tool like SUSE Manager that not only helps in the deployment of patches and fixes, but it can actually help in the deployment of live patches. You can schedule the live patches and be able to deploy those off hours if that's what your organization needs to do, and do it in an automated way. The availability, as you can see, is listed here for Power-based systems. Live patching has been available with SLES 12 since Service Pack 2. So it's absolutely available if you're staying up on with the latest versions of SLES or SLES for SAP applications. So I definitely, like the previous SUSECON sessions that I've highlighted, there is a kernel live patching methodology session, as well as others that I recommend you checking out as part of SUSECON Digital to get more details around live patching and its capabilities. So Mark took a few minutes to talk about VPMN, Virtual Persistent Memory, and I've spent several minutes and several slides talking about SUSE Linux Enterprise Live Patching. One of the questions that I've gotten regularly is does VPMN diminish the need for live patching? And I believe the answer is no. I believe VPMN and live patching are complementary technologies. VPMN helps minimize the time to reload the HANA database in memory after reboot. Live patching minimizes the number of reboots due to kernel security patches and things like that. You can use these two in combination with each other and use them effectively to help minimize the amount of downtime that you have. VPMN is focused on Power 9-based systems. For those customers that are still using Power 8-based systems, VPMN currently is not available. And so you absolutely want to take advantage of live patching with Power 8 systems to minimize the reboots and things like that. So with that, I'd like to quickly summarize what we have discussed during the session. First of all, SLES for SAP for IBM Power includes the HA resource agents for SAP HANA and SAP NetWeaver NQ replication. IBM Power 9 systems, and I see a typo there, I apologize, that have Power VM have the virtual persistent memory. So Power 9 systems with Power VM have virtual persistent memory for being able to do fast restarts of SAP HANA. Live patching is a complementary technology to virtual persistent memory that enables the patching of the kernel without the need to immediately reboot the system. And with that, I'd like to thank you for taking the time to listen to our session, and absolutely check out the rest of the amazing sessions at SUSECON Digital. Thank you very much.